It's thinking. There we go. It stopped thinking. So if we have an ion, which was yesterday's, and that was this guy right here, what type of element in general, yes, I know there are some exceptions, but what type of element is going to lose electrons? Nope, noble gases don't give a crap about anything. They're fine. Hold on. Lose electrons to become positively charged. They tend to be metals, except for poor little hydrogen, which is like, I'm so sorry, y'all, but unfortunately in this class, there are a lot of exceptions. Okay, but most elements, in order to lose an electron, they're going to be positively charged, which tends to be metals, except for hydrogen, because it's weird. And so which types of elements gain electrons? In general, rule of thumb, nonmetals, and they are anions. It is anion and cation, not anion and cation, which cation, they're ions, cation and anion. And then there is an assignment that's in Canvas. It's like a Canvas quiz. It's completely and totally online. There's no paper version of this at all. Don't do it yet. Just wait. Patient. Did anybody else need a paper version? I get everybody. So notes 19. Some of the other teachers smushed together 18 and 19 because they really go together. And if you understood, what's going on yesterday, then today is just as easy. They're related to each other. Here we go. So I've said this repeatedly. It's not been like words on the screen, but the way that elements talk to each other are these outside electrons that we call valence electrons. That is their language. That is their vocabulary. It's almost like we've all put puzzles together. And if you've never put a puzzle together, I'm so sorry. It's like never having a rubber ducky. I'm so sorry. Okay, but they have pieces that fit with other pieces. That is their valence electrons. That's literally how they talk to each other. And if any of you go off to do higher level chemistry stuff in college, not regular chem, 101 and 102. I'm not talking about that. I'm talking about what I did, biochem, organic, biochem. I didn't understand this stuff until I took biochemistry. You take organic before you take biochem. I tried to memorize organic. You can't do it. I didn't understand organic until I got to biochem, and I said, oh crap, what I was learning literally was an alphabet. And now I'm learning how to make words. And you literally have to approach it that way. So if you go into any kind of medical field, pharmaceuticals, anything along those lines, you cannot memorize this stuff. It's not like biology, which I'm not knocking biology, I'm not. You have to learn the language. And that's the best way that I can explain this. So valence electrons are the language of atoms when they decide to buddy up to somebody else. They're by themselves, they don't care. They don't crap. They don't. They're fine. But as soon as they start making a compound, a ionic or covalent for that matter, if we're going to start with ionics, as soon as I start making a compound, then we have to deal with these. I have to take these ears off this. You have to deal with, do they gain or lose electrons to be like these noble gases? specifically with ionic compounds. This is the ones that we start with. Your noble gas, specifically, and for those of you, oh shoot, I hope I'm not muted. Look. No, I'm not. Okay. I only see the two. This one. Okay. So this P6, this is a noble gas. So for those of you that are online, this right here, this sixth element over within the P block. And I did print out more of these colored, oh, they're not colored, but the two color periodic tables if you guys need them. This is a P6 all the way on the right, with the exception of helium. Helium is the exception to the rule. That's what makes them inert, stable, non-reactive. There's all different kinds of phrases that we could use for a noble gas electron configuration. I'm really hoping that I underlined what I was supposed to. I did not. It wouldn't surprise me if I missed something. So, and there's a very good chance that I added something extra into this that I know is important, but for whatever reason that this district does not put it on here. I'm trying to abridge their notes with my notes, make it a happy medium, if you will. But you've got an exception. Most elements want 8, except for the ones that want to be like helium, which actually wants 2. There's elements 1 through 5. If I made your test, I would put this in there as a trick question. The octet rule does not mean 8. Octopus, octagon means 8. But the octet rule technically does not mean 8. It means it wants to be like the closest noble gas. And in the case of helium, that's numbers 2, because the first shell holds 2. All the sequential shells after that can hold a maximum of 8. So I am not the one that's responsible for making your normal tests. I'm not. I'm sort of following everybody else, if you will. But octet does not really mean 8. With the exception of those 5, yes, it does. But for those 5, it means 2. And really, like I said, the only exception is helium. So, example, argon. On your periodic table, and yes, I printed out more of these. It just doesn't look exactly like mine because this is ancient. I've had this for years and years and years. But if we have argon, I know y'all can't see it online, but argon, which is number 18, we've got 1s2. This is the second level down, 2s2, 2p6. The third level down, 3s2, 3p6. To make it a superscript, if you guys are trying to figure out how to do that with Google Docs, if no teachers ever educated you before, you highlight what you want to make a superscript and you hit Control, period. Makes it a superscript. Control, comma, makes it a subscript. You're going to use those a lot in this class. But argon, where's my good laser? So argon, which is, if I'm not mistaken, is right there. So we've got the first row down, 1s2, 2s2, 2y, then 2p6y, 3s2 and then 3p, it's 6 across. That's where we are getting these numbers from. You're literally reading it left, right, top to bottom, like how we do it, like a book. Argon is way over on the right-hand side, along with helium, neon, krypton, radon, and I think xenon is the other one. Those are noble gases. They are inert. They have a full outer shell, and honestly, they don't want to react. Can we force them to? Yes. Do they want to? Mm-mm. The whole point of these things, excuse me, making compounds, is they want to have this full shell. They don't want to react. They don't want to, but they're forced to. And that's the whole +1, +2, +3 stuff that we put across the top. And once again, if you did not either, especially those of you that were remote and switched, if you need one, I do have blank periodic tables that can be colored. You just have to go back to the right slide to color them back in. And we did add stuff to it yesterday. We added +2 to zinc and cadmium and +1 to silver. All right, noble gases. Helium is the exception. I said, I'm so sorry, y'all. But there's a reason why chemistry is probably going to be the hardest science that you take all year. There's so many but this. Okay, helium is a but this. Helium does not want 8. The first electron shell can hold 2. And if it has 2, it's full. And so helium is considered a noble gas because it has a full electron shell. It doesn't need a P6. And I really need to laminate this puppy. Helium is literally the first period down. It is the second element one. The first electron shell can only hold 2. Why? God made it that way. And so it can't have more than 2 on the first shell. Every shell beyond that can't hold more than 8 as a maximum. I'm so ready to get into naming stuff, like teaching you guys. I think I showed you guys this yesterday, that there's 2 different types of iron, right? So sometimes iron is +2, and sometimes it's +3. It's just different types of iron. For lack of a more PC way to put it, the biggest Huchima of the periodic table is manganese, and it's got 7 different types. It bonds with everything it comes across. But oxygen is always -2. And these 2 compounds are not the same thing. When this makes a compound, this is rust. Like you leave your bike outside and it rains and it makes rust. This is rust. This is not rust. They are not the same thing. And it has to do with these oxidation charges. And I know those of you that are online, I'm so sorry because you can't see what's on the board. So in general, a valence electron, VAL, if you see VE, that means valence electron. It's just for your information in the future. But the total number of electrons that are present in any kind of config is important. And specifically, it's the very last bit that's the most important part. That tells you how many bits are there that tries to combine with something else. It might have 2 bits. It's easier to get rid of 2 bits than it's gain 6, but it still has 2 bits. Just like a puzzle. That literally is an electron's, I don't know which one, an atom's language. That's how it talks to other atoms. Now I have, and they're down here somewhere. The problem is it's not supposed to let y'all touch stuff, which cuts down on labs. But I have these, I don't know where they are. That's not it. That's not it. I have these ion chips. I have no idea where the heck they went. Nope, that's not it. It's gonna be in this one. My mole hawk. We missed mole day. This is my mole hawk. Here we go, ion chips. We missed mole day. Mole day was October 23rd. With all this COVID crap, it's ruined everything, unfortunately. Okay, but I had these ion chips that is it. I know a lot of you guys are hands-on. Looking at crap like this doesn't help you. Actually, manipulating things with your own hands helps you. Huh? Yeah, until COVID gets spread rampant. Yeah, I'm getting started. Y'all do not want to go back home again.
Nobody gets corona in here.
Nobody's got corona in here. No. I was gonna say, y'all are the age where you have it and you don't know it because you're not old enough to have effects, if you will. Whereas my age, yeah, I'd probably kill me. I don't want to get COVID. I don't want to get COVID. I'm old enough. I don't want to get COVID. Now, your valence electron, that's what Val-E means, valence electron. For your representative elements, your group A's, it has to do with which row it's in. So group 1 has 1 valence electron, group 2 has 2 valence electrons, 3 has 3, 4 has 4, 5 has 5, and so on and so forth until we get to 8 with the exception of helium, because that's the weird dude. If you have not done this yet, which we did, and I know that some of you switched from Cowan to me, okay? But you should put, if you have not done so already, on your periodic table, over group 1 should be +1, group 2 should be +2, group 3 should be +3, plus minus 4, minus 2, minus 2, minus 1, 0. Yeah. Let you. Yes. Group B's are different. These guys in the middle that we put the orange lines across, if you were here, and like I said, I'm so sorry because a lot of you switch from one teacher to another. But this group in the middle, transition metals follow a different set of rules. And I talked to Ms. Castleberry because she's the chemistry lead. And I said, do I have to just teach them Roman numerals, or I have to do both the Roman numerals and the names? She goes, yeah, don't do the names. The names are a world pain in the butt. But your group B elements, these guys, so these guys here, these guys, with the exception of zinc, cadmium, and silver, which these were +2, and this one was +1. All the other ones have more than one type, just like iron. It's not always +2 and +3. Sometimes it's +1, +2. With the case of manganese, which, like I said, is sort of like the hoochie mama of the periodic table, it's +1 through +7. Manganese, it buddies up with everything. Let's just put it that way. You guys have, what area code is 956? Should I answer it? Sure. Why? Like every time. Go away. Die. Die. Wait, that's all I get. It's like telemarketers. It's either that or it's the school saying that, oh, your kid had close contact at recess. Oh, great. So whatever. At recess. At recess. That's the whole reason why I wasn't here. So yeah. What who? Huh? What? Hold on. Alrighty, so sorry, I got all kinds of weird crap going on. You guys have this. If you do not, I ran off more copies, which are here. If you either did not do a color periodic table, which some of you came from Miss Cowan, or if you lost it, the dog ate it, aliens abducted it, I don't fucking know. But group 1, you should have a +1. Group 2, you should have +2. These do not count. These are different. But you should have a +1 and a +2 in these 3 boxes. And those boxes, +3, ±4, -2, -2, -1, 0. These will help you tremendously when it comes to creating ionic compounds, which is what we start with. Some of you are going to like ionics way more than covalents. Some of you are going to like covalents way more than ionics. They have a totally different system. All right, barium. You guys should, yes. Okay, so barium. On your periodic table, barium is right here. It's in group 2. So how many valence electrons does barium have? It has 2. Is it going to want to lose 2 or gain 6? Lose 2. They always can do the shortest path possible, whatever's the quickest route, if you will. They're lazy. Carbon is in group 4. Now, it has 4 valence electrons. The carbon group is weird. They can either give away or gain. That's why it's +4 -4. Iodine. Iodine's in group 7. It has 7 valence electrons. Does it want to gain 1 or lose 7? It wants to gain 1. That was yesterday's assignment, which I still have a few of them that were being turned in. Got one from Jared, Kyle, Sahara, Veronica, Matthew. Those are the ones that I see right here. But you're literally pulling this stuff off of this periodic table. And now there was a reason why we spent an entire day color coding this. This is your cheat sheet for the entire year. Do not lose it. Once I tell you that there's nothing else that we're going to put on there, if you have a way to laminate it, laminate it. Now this guy, Lewis dot structures, or Lewis dot diagrams, I've heard it said both ways. There's a specific way but we put electrons around the symbol. It is not a circle. It's almost like draw a box, and you put the dots on the sides of the box. It's not a circle. And it's going to end up going in order. 1, 2, 3, 4. Then always up top again. 5, 6, 7, 8. Now, am I gonna like really get after you if you don't have it exactly in the right spot? No. Okay, but you each north, south, east, west gets 1 before you duplicate. And normally it's the top part that gets the second one. Ooh, it's the top one that gets the second one. As far as the way that we draw these things. And I can't remember how much of this, no, you guys actually have the numbers on your canvas. But this is a Lewis dot diagram, Lewis dot structure. There's different phrases, but it's a Lewis dot something. And these dots are how many valence electrons they have. It's the same number as how many that's in their group number. Once again, not a circle, literally like a box. You got north, south, east, west. Okay, so sodium. Sodium is Na. Once again, if you have not started looking at set number 3 on your elements, that's the quiz that's tomorrow. Sodium is Na, it's in group 1, it's got 1 valence electron. Boron, the letter B, is in group 3, it's got 3 valence electrons. Oxygen, the capital O, is in group 6. It's got 6 valence electrons, and argon, which is a noble gas, is in group 8. It's not the exception. It's not helium. It does have 8 valence electrons. So how many dots does Na get? How many valence electrons does sodium get? 1, which is on the right-hand side. Now, how do you guys do this in Google Docs? I didn't create dots to put on there for you to like control C and V, but you should be able to add a circle and move it over there. Boron, the capital B, how many dots is it gonna have?
3.
3. And we're gonna do right, left, top. It's right, left, top, bottom, and then we go from top in a clockwise pattern across it. Oxygen has 6. So we're going to do right, left, top, bottom, top. I lied and did not animate this one. Top then right. Argon has 8. It's going to have all 8 that are full. The only noble gas that does not get 8 electrons in its outside shell is helium. Helium only needs 2 to be full. Now we've got just under 10 minutes. Some of you are wanting to do stuff through Canvas and submit it, and some of you want paper. And as long, hold on, let me stop this.